Hello everyone. In this lesson, we will learn how to check convergency and divergency of the series. So I have taken this question here. This is a series as summation sign is there. So this is a series. If there will be no summation sign, like if I will take fn equal to x square, this is a sequence. So how to write sequence? Let's take n equal n tends to 1 to infinity. So how to write sequence here? X to the power, let's take x to the power n, x to the power 1, comma, x to the power 2, comma, x to the power 3. This is your sequence. But if I'll write it down by giving summation sign, x equal to 1 to infinity and x to the power n. So if summation sign is there, this means this is a series. So we will write series this way: x to the power 1 plus x to the power 2 plus x to the power 3. So this is a series and this is a sequence where term separated by comma in sequence, and here we will give plus sign in between two terms. So as this is a series, we are going to prove that this series is divergent. Okay, so let's open this series first. So write down here, this is our series n equal to summation sign n equal to 0 to infinity cos of n pi. This is a series and we are going to open this. So substitute n equal to 0, 1 and 2, and we have to write in this way by giving plus sign in between two terms. So in place of n, just write it down 0. So cos of 0 pi will be the first term. Then in place of n, substitute 1. So cos of 1 pi, and then plus cos of 2 pi plus cos of 3 pi. And this way, the summation sign, the series will go on. Okay, this way summation sign go on, and last one will be cos of infinite times pi. Now let's one more step we will do. Cos of 0 pi means cos of 0, cos of 1 pi means cos of pi, plus cos of 2 pi plus cos of 3 pi. Now we will write down the value of each cos here. So cos of 0 will give me 1, plus cos of pi will be minus 1, plus cos of 2 pi will be 1, and plus cos of 3 pi will be minus 1, and this way we will get the series. Now let's one more step we will do it here. 1 minus 1 plus minus minus 1, then plus 1, then minus 1, then plus 1, then minus 1, then plus 1, then minus 1. It will go like this. Now what we can see here, when n is equal to 1, so we will get minus 1. And when n is equal to 2, we will get plus 1. So what does that mean? We can write it out there. This is oscillatory series. We are finding here oscillatory series. So very difficult here to say whether this series is converging or diverging when we will get oscillatory series. So now we have to show here when n is odd, then what we will do, we will find limit n tends to infinity cos of n pi. We are writing this as a sequence, not series. This is a series we have taken. Now we have to find, always we need to find, write down this series as sequence, like fnx equal to, we have to take cos of n pi. Okay, or you can write it down un equal to cos of n pi. Whatever you want, you can take as sequence. So when we will write down sequence and when we are going to find the limit n tends to infinity, and when n is odd here, when n is odd, we will get the value of cos will be minus 1. when n is even here, and limit n, when we find the limit of this sequence cos of n pi and n is even, we will get plus 1. Okay, so this is the n by nth term test. We did here nth term test. Therefore, this is the nth term test, and by nth term test, this series is diverging. By nth term test, this series is diverging. Now we will do next question here. So we have this question. Consider the following series, summation of n equal to 1 to infinity n plus 1 over 2 n whole to the power n. And we have two special test is given here. We have to use nth root test to show that this series is convergence. Now we have to show that this series is convergence. So how to check by nth root test? So nth root test is, we have to find this one. Limit n tends to infinity and nth root of a n. First find out the sequence. As I said before, a n equal to this sequence is n plus, this is series of a function. This is a function here. So we have to take the function, okay, out. So n plus 3 over 2, and this is a function we have taken, and this is a series of a function. So first one is, if you substitute n equal to 1, there will be a different function. Then n equal to 2, there will be a different function. So here we are getting a1, a2, a3. So this is the series of function. So this is a function we have taken, and this is n. And by nth root test, we will find nth root of an. This nth root of an, find the value of this. And if we will get less than 1, then this means series is converging. This series is converging. If we will get greater than 1 or infinity is also greater than 1, so the series will be diverging. And if we will get equal to 1, so we can say that inconclusive. So we can't say anything, either series is converging or diverging. So we will have to apply some other test. So here you can write it down, inconclusive. Now start this finding this series, whether this series is converging or not. So we have to find limit n tends to infinity. Nth root of an. An is what? An is this function, n plus 3 over 2n, n plus 3 over 2n whole to the power n. This is a function we have. Now next step will be limit n tends to infinity, nth root. If x to the power 2 to the and this is, if we will take it here, cube root here, say that here cube root x to the power 2. So how to solve this one? We will write x to the power 2, and this cube root will become 1 over 3. Same rule apply, we will apply it here. So n plus 3 over 2n whole to the power n, and this n, what we will write it down, whole to the power 1 over n. Now, if anything power to power, both power will multiply. So limit n tends to infinity, n plus 3 over 2n whole to the power n multiplied by 1 over n. So this n will be cancelled. Now we have left here limit n tends to infinity, n plus 3 over 2n. Now we can find here limit here. What will be the value by simply put it limit formula, or we can use L'Hopital rule. So I'll explain you both rule how to find it. Let's find it out in a simple way. So as you can see how to find limit of this function here, or both numerator and denominator power is same. So when into the rule, when to find limit n tends to infinity, when power is same, what we will do, we will divide numerator and denominator by n, same power. So n plus 3 over n all over 2n over n. So here it will be cancelled. So limit n tends to infinity. Here we will separate it, n over n plus 3 over n. Okay, let's do one more step here. Or we can leave it here this way. And here all over two left we have. So this will be cancelled. So limit n tends to infinity. We have left here 1 plus 3 over n over all over 2. Now substitute limit n tends to infinity here. So 1 plus 3 over infinity and over 2. So what we will get, 1 plus 3. If you divide any number, 3 is a very small number, and if we will divide this very large number, we will get not 0, but it will tend to 0, tending to 0. So we can write it down 0 here all over 2. So what value we got? 1 over 2. And nth rule says when you get less than half, the series will converge. So here we got here less, which is less than half. So this means series is converging. Now I'll explain you how to use L'Hopital rule here from, let's apply it from here. Yeah, here I said you can apply L'Hopital rule here. So let's start from here. Here I'm going to explain you how to apply L'Hopital rule to find the limit. So let's write it down first. Limit n tends to infinity, n plus 3 over 2n. Simply you divide by n, but if you don't divide, and you can find this way, your function is apply L'Hopital rule, divide this dy over dn, whatever variable you have. I have here n, so we will differentiate with respect to n in denominator and differentiate with respect to n denominator and numerator both. So limit n tends to infinity and differentiate. So if you will differentiate, you will get 1 plus, and differentiation of constant number will be 0, and here you will get 2. So what you get? 1 over 2, which is less than 1. So series is converging.